Welcome to Lesson 7. We have made a lot of progress. To lock it in, we will use this lesson to present another example. That should ensure the relevant ideas are fitting together nicely and you are comfortable with what we call Maths Lite. We will use a scenario of going on a trip. That's the story that the maths is going to apply to. And it will generate a convenient total, which gives a structure to our work, and that total will be based upon distances, as you will see. For our type 1 situation, we generate examples. And this will be summarised in a table given here. We'll call the distance travelled before lunch the variable B. The distance travelled after lunch, the variable A. And the distance travelled in the day, T, representing total distance. Now, if the distance before lunch is set at 100 and the distance after lunch is allowed to vary depending upon the circumstances, the distance travelled in total during the day will vary as well. So here we've got the distance before lunch is a fixed value. We call it a constant. The distance travelled after lunch is a variable. And the total distance travelled depends upon how far we travel after lunch. So it is a second variable referred to as a dependent variable. It depends upon what happened to the other one. So notice that I've kept the distance travelled before lunch at a fixed amount. And I've allowed the change, the distance after lunch, to vary between 1 and 400 kilometres. There are other ways of looking at the situation, but they don't alter the basics of what we're setting out to do. Now, type 2 question needs a missing component, such as if we do 100 kilometres before lunch, how far do we have to travel after lunch if the destination is 300 kilometres away? A relatively simple question, but it's based on the structure we had in the table. So a summary of our scenario. It can be represented by the equation before lunch plus after lunch is the total distance travelled. Or in an abbreviated form, before, after, total. So a specific problem mentions before, after, and total. So our calculation, a statement of what has happened, isolate the unknown, and draw a conclusion. In line 1, a missing value is to be determined. In line 2, we reverse the change specified in line 1. And line 3, drew a conclusion about the missing value. If we look at the 2 pages together, there's the scenario represented in a mathematical form, putting the details of our specific problem, we draw a conclusion. This problem could have been presented without a scenario by simply supplying the first line of our calculation. Then it would be referred to as an equation question rather than a problem-solving situation. Now for type 3. The total is generated by considering distance before lunch and distance after lunch. So what we consider to be a result will be that total for the day. This means the label for the vertical axis will be total distance, and the horizontal axis represents what can change, and that is the distance travelled after lunch. Remember, the distance before lunch was set. We can use our samples from the type 1 discussion previously, and our basic illustration or graph has the input leading to the output. And we place some dots to represent the combination of values shown at the top of the page. So here's the graph. The dots have been connected to make a line because all distances are possible. It's a little artificial to say we'll go 100 or 200 or 300 kilometres after lunch. So, as an overview of Maths Lite, we have the following. A scenario, a simple statement about what is going on. It will indicate what's involved and how these things are related. When the relationship is abbreviated, it's called an equation if there's no practical context. And it's referred to as a formula if there is a practical context. In mathematical terminology, a function describes the cause of the change. This is done to put an emphasis on how the quantities can be changed. There are three things that you, the student, can be called on to do. Type 1, generate examples of what can happen, as we did. Type 2, complete a specific case, which we did. That's called solving. And type 3, make an illustration of all possibilities. If you were comfortable with what we did, you will be comfortable with what you could be asked for in the future. Now note, type 2 takes one of the type 1 cases and makes it complete. Type 3 uses all of the type 1 cases and makes a picture. Type 2 is referred to as problem solving if the practical context is emphasized. It is the details of the situation which tell you what is involved and how they relate. They make any numbers relevant. How the parts of the calculation relate is often based on this general statement. The result is what you start with, modified by how it changes. Now that can be stated in reverse. What you start with, modified by how it changes, gives the result. Both are true statements, both are basically the same statement. When a problem scenario is based on a practical situation, the relevant statement is usually based on the first possibility, that is, this one. So the target variable is written before the equal sign, which in a worded statement is the word is. Different practical scenarios can introduce other ways of changing a starting value. For example, a restaurant adopts a seating plan based on small square tables. Each table will have 2 chairs. A possible question is, how many chairs do they need? Now, we'll analyse that as a maths problem. What was related? Tables and chairs. Is there a numerical link between them? Yes. And the 2 supplies that numerical length. Each table will have 2 chairs. So the number of chairs has to be double the number of tables. As an equation, number of chairs is equal to the number of tables multiplied by 2. In other words, doubled. Or we can write it with the 2 before the t. The number of chairs is twice the number of tables. And what is the emphasis here? How many chairs are needed once we have tables? That's the emphasis, because in the equation, the number of chairs is related to the number of tables. The number of chairs depends upon the number of tables after we've changed that number. So notice how I've written the equations here. In this case, the result is represented by the letter C, the number of chairs. And I've written that at the beginning because that's the scenario's emphasis. This is the most common way of writing a formula in mathematics. What you are interested in is represented by a symbol which starts the formula. In conclusion, notice that we have lots of words here and not many numbers. That's because maths is thinking about relationships and not about counting. Numbers are only used when we want to illustrate possibilities. That is important. Numbers are only used when we want to indicate possibilities. So if we go back and look at those formulae, the number 2 appears, but it is the letters indicating what is relevant, which is the most important. The number of chairs and the number of tables are related. The 2 appears to indicate 2 chairs per table. In other words, a doubling of the table number. But notice, numbers such as 2 3s are 6, they are only relevant when we come to examples. So we've covered quite a lot here today. We've put what we've learnt previously into a context to see if you really understand what we're dealing with. I'm sure you do, and we'll build on that again next time. See you then.